right, so what we're going to work on today is graphing and translating radical functions. So square roots and cube roots are going to be the focus. At the top here, I just had some visuals for you to look at. So the very first graph here is just actually quadratic. It's y equals x squared. The square root function is the inverse of the quadratic function because a square root and a squared cancel each other out. They undo each other. So these two functions are inverses. I'm sorry, this is a function because it passes the vertical line test. What you have here, basically the sideways u, this is plus and minus the square root of x. This does not pass the vertical line test, so it's not considered a function. Now, to consider it a function, what we do is we're going to restrict this. So instead of having the plus and minus, we either just have the plus, which you're not going to see the plus sign written in front of it, but that's what's going on here. And that has a general shape, kind of like the top half of that sideways U. Then this passes the vertical line test and is a function. The other way you can do this is the negative square root of x, which is the bottom half of that U shape only, and it's restricted, so it go ahead and be a function by passing the vertical line test. Now, what we're going to add into the mix, you're either going to be graphing something that looks like this or something that looks like this, just a general shape. We're going to be translating these today, and so I'm going to give you some rules here. So, a vertical translation, I'm just going to do a really basic, is going to be a translation that moves up or down. So if we're doing a vertical translation, we're going to take this graph or this graph and move them up or down. What you're going to see is some number, and I'm going to represent that with a k, outside of the square root. Outside moves it up and down. Okay? A horizontal translation is going to either shift your graph left or right, and this is going to happen inside the square root, all right? And I'm going to write it like this, y equals, not absolute value, square root of x minus h. Okay, here's the deal. If it's outside and it's positive, it's going to go up. If it's negative, it's going to go down. If it's inside, it's going to be the opposite of what it looks like. So if it looks like a minus, it's actually going to go to the right, and if it looks like a plus, it's actually going to go to the left. And then for your diagonal translation, that's going to be a combination either up or down and left or right. So we would have both together. That's going to look like this. Square root of x minus h, and then the plus k on the outside. Okay, and then the hk is going to be your starting point. Now for these, I'm not going to have you guys plot specific points. We're just going to do a general graph. So I'm looking like, did you start it in the right spot? Does it look the right picture? If it's positive, it's going to be the top half of that sideways U. If it's negative, it's going to be the bottom half of that sideways U. The other thing to remember, you cannot take the square root of a negative number. Okay, so here's some graphs. I'm going to start out by writing the starting point, and then we'll deal with domain and range in a second. Okay, there's nothing inside with the x, so it's not shifting left or right. So since there's nothing inside there, the x coordinate of where I'm going to start is 0. This 3, this plus 3, is going to shift the graph up 3 units. This is a positive square root of x, so that's the top half of that sideways U shape. And so that'll be the general, what I'm looking for in terms of the picture. So where are we going to start this? Just find that point, 0, 3. And then we're just going to kind of do a little swoosh to the side. It's the top half of that sideways U. Okay, domain and range. Domain is how you move left and right. Range is how you move up and down. Domain deals with x values, range deals with y values. Now here's the deal. If you're doing domain, come from the left side of the graph, and the first point you touch, and be real careful with this, I need the first x value you touch. The first point I touch is going to be right there, and the x value at that point is 0. So I have an actual point there, so I'm going to put a little bracket, 0, and then comma. This points to the right forever, so these numbers are all going positive, like 6, 7, 8, 9 this way. So this is going to go up to infinity. And if you guys remember, if you're doing infinity, that has a parenthesis because it's not a specific value. Okay, for range, you want to come from the bottom of the graph. The first point you touch is going to be right where we started there, but this is asking you for y values. So the first y value I touch is going to be right there at 3. And this does curve to the side. It does not flatten out. It does move up. It just goes very gradually. And so this would eventually go up forever. So in terms of the y values, you're going up to positive infinity. That would be your domain and range. If you prefer the inequality notation, we could do that too. This would be x is greater than or equal to 0, and this would be y is greater than or equal to 3. So interval notation and then inequality notation. Okay, so we'll do one more. Nothing inside with the x, so we're not shifting left and right. We got a -2. This is going to shift us down 2 units. So 0, -2. That's going to be my starting point. This is a positive square root of x, so it's the top half of that sideways U shape. So just a general. I'm not plotting specific points. I'm just looking for that general shape and the correct starting point. Domain and range super similar. So the first point I touch here, x value of that point would be right here. And so that x value is 0. This points to the right forever. We're going to infinity. The range, the first y value you touch is that same point, but the y coordinate there is -2. And then it moves very gradually, but this does go up forever. So that's going to positive infinity. Okay, now the last one here. Whatever is inside here, it's going to be the opposite of what it looks like. It's actually the value that would set that equal to 0, and that's where that's going to start. So if this is a +4, -4 is actually going to be the starting spot. So inside, it's the opposite of what it looks like. Outside, you're going to go ahead and copy. There is nothing outside this square root, so I'm going to have 0. So this is just going to shift 4 units to the left. So here's my starting point, positive square root of x, same general shape, the top half of that sideways U. First x value I touch is -4, and it goes and points to the right forever, so to infinity. The first y value that I touch as I'm approaching here at this point is 0. And these are brackets again because I actually have a point there. This gradually goes up, but it does point up forever, so that's going to infinity. Slide these up, and I just got a bunch of different options here for some practice. Okay, so square root, this is a positive square root, so general shape should be that. Opposite copy for -1. And so we're going to find for -1, general shape's going to look like that, the top half of that sideways U. My first x value that I'm going to touch is 4, and that goes to the right forever, so infinity. My range, the first y value you touch, that same point, but it's going to be -1, goes up forever, infinity. Next one, opposite copy, -2, -5. And so we're going to plot that point. This is a positive square root of x, so that same general shape we've done so far. We're going to do negatives on the next two for some practice there. Domain, first x value you touch is -2, goes to the right forever, so positive infinity. For the range, come from the bottom, the first point you touch is that same point, but it's going to start with your y value, which is also written up here, that -5. This goes up forever, so that's going to go up to infinity, your possible y values. Okay, now, here I have negative out in front of the square root of x. Everything else we have done up until this point is going to be similar. When I graph it though, this is the bottom half of that sideways U shape. So the graph is going to actually swoop down. You still do opposite copy, so -3, +1. And that's going to be right here. And then I'm just drawing the bottom half of that sideways U for my graph here. Now the domain and range, make sure you're watching this. The first x value you touch is going to be that -3. And then this points to the right forever, so this is still going to go to positive infinity. Okay, now for the range. Now this is a little bit weird to decide on this graph here. Okay. this is going to point down forever eventually. It's kind of a very gradual, but it would point down forever. Now, as I'm approaching this, if I could see a bigger picture of the graph, I would be touching part of the graph until I got to this as my stopping point, and then there's nothing above that value. So this actually, we're going to go down to negative infinity here, and this is going to be my stopping point. That y coordinate is going to be where the graph stops. So this goes down forever. It stops at a y value of 1. There's nothing above that. So it's just a little different when you do the range. The domain should be the same format, but the range is going to be different if you have the negative in front of your square root. Okay, so opposite copy one more time. This is going to start at the point 2, 1. Again, I've got this negative out in front, so it'd be the bottom half of that sideways U shape. My domain, first x value, approach it from the left. The first x value would be 2, and it goes to the right. It's going down, but it's going to the right forever, so we're still going to positive infinity. Remember, you can't take the square root of a negative number, so it's not going to swoosh back that other direction. And then for the y values, again, it's very gradual, but this points down forever. So this would go down to negative infinity, and it would stop at this y value, which is 1. And that has a bracket because I have an actual point there. Okay, so here on the back, we're going to do cube root functions. So just so you guys could see a visual, this first graph here, this is y equals x cubed. So to cancel out that third power, we would take a cube root. So the x to the third, the cubic, and the cube root, those are inverse functions. So these two are inverses of each other. And you guys will see that it doesn't matter. This is a function, period. It passes the vertical line test. This is a function. It passes the vertical line test. We don't have to restrict anything. When you do take a cube root, you don't put the plus and minus symbol. That's only for even roots. So a third or a fifth or something like that. They don't have a plus and minus. So this would just be like a plain cube root. If you have a negative out in front, that does affect the graph. It flips it the other direction. So these are the two general shapes. Everything else I'm going to give you here is going to be very similar to the square root function in terms of like how to find points and things like that. But in this case, instead of having like what I called a starting point on those square roots, what you're going to have for the cube root is where I had my starting point on these, it's going to be the point where it switches direction from one way to the other. You can take the cube root of a negative number. That's why we have both of these possible options here. Okay, so vertical translation. Again, it would be up and down. It's going to look something like this. Y equals cube root of x plus, could be minus, something on the outside. That's going to move it up and down. Horizontal, left and right, again, like the square root, the translation there would be inside the cube root. Okay, if it's outside, you just copy that. If it's inside, you do the opposite of what it looks like. It's where it's going to switch from one direction to the other in the cube function, or cube root, excuse me. And then finally, a diagonal translation would put those together. You'd have a number inside and a number outside. And again, inside you want to do the opposite of what it looks like, and then outside you want to go ahead and copy that. Now the H and K there, that would be, again, that point where the graph switches direction. So something like this is going to be where it switches from one side to the other, but these are the general shapes we're going to work with. Okay, so let me slide this up here. All right, so this is a positive cube root function. So that sweeps forward and backward down like that. That's the shape I'm looking for. The point right in the middle, you're going to do opposite copy. So this is going to be positive 4, positive 3. So we're going to go ahead and plot that point. Just swoop up to the front, swoop back. Just looking for a general shape there. Now, domain and range for every single one of these is totally the same. This goes, because you can take the cube root of a negative, left and right forever. So negative infinity to infinity. If you wanted to think about inequality notation, you might see something like that, all real numbers, because I do cover the entire x-axis. And it's going to be the same for the range. This part goes down forever, this part goes up forever. So this is also going to be negative infinity to infinity, or all real numbers. You're going to cover the whole y-axis, the whole x-axis. So these are a lot quicker to do domain and range. They're always going to be the same. And it doesn't matter if you have a negative in front or not. We'll talk about that in a second. Okay, so to find that middle point, this is a positive cube root. So I know it's going to sweep up to the front and back to the left. Opposite copy, this is 3, -2. To find that point, you're going to sweep up to the right, back to the left. Domain, it goes left and right forever, so you're going to cover the whole x-axis, negative infinity to infinity. It's going to go up and down forever. You're going to cover the whole y-axis up and down to infinity. Okay, now, only difference down here, just pay attention to these. This is still a cube root, but on each of these I have the negative out in front. So that is going to have that middle point, but it's going to go up and to the left, and then it's going to go down and to the right. So the shape is going to be kind of flipped over from what we just did. Still opposite copy, so -2, -3 here. And then just going to, because of the negative, this swoops up to the back, down to the front. And now, this, even though it's flipped over, this still goes to the left forever, this still goes to the right forever. So even though it's flipped around, you're going to cover the whole x-axis. For your range, again, even though it's flipped over, this side would go up forever, this side would go down forever, so you still cover the entire y-axis. And so it's going to still be negative infinity to infinity, or if you prefer all real numbers, you can write that down too. I got one last one. Opposite copy, -3, 1. This has got the negative in front, so it's going to swoop up and to the left, down and to the right. Domain covers the whole x-axis, negative infinity to infinity. And up and down forever covers the whole y-axis, also the range negative infinity to infinity.